Okay, this series that we just did is called Maclaurin series, and it's also a Taylor series, but Taylor series is slightly more general. And I'll revisit that question that you had about what the difference between Taylor and Maclaurin. Right now, we'll just call it Maclaurin. And then when we see the Taylor series, I'll be able to explain the difference. Well, Maclaurin series is a special case of the Taylor series.
Okay.
Okay. So, yes.
But where would you plug in point 1?
Right. So that's what I'm about to do. Yeah. That's exactly what I'm about to do. All right. So remember our original question was sine of 0.1? Right. Now let's actually plug 0.1 on the right side and see what you get. Oh, by the way, who has calculators? Anyone with a calculator have it ready? Put it in radian mode. Okay. This is like, you know, when a magician is on the stage, like they ask everyone to like pull out their watches or something. Yeah. So that's what I'm doing here. So now I'm going to plug in 0.1 here. So it's 0.1 minus 1 over 3 factorial 0.1 cubed plus 1 over 5 factorial. Well, this is 6, so I'll just put 6 there. 5 factorial is 120. And now look, 0.1 to 5th power is a very small number. This is actually 0.00001. And then you're dividing that by 120, so it's even smaller. So things that appear from this point on, we can just neglect. Okay? And we can say that these two are good enough approximations. And by the way, in the graph that we saw, this graph, x minus 1 over 6x cubed, was virtually identical to sine x near 0, right? So if you're close to 0, this is a very good approximation. Okay, 1 over 6 is 0.1666, so on, right? Times 0.1 cubed would be 0.001. And we say this is the approximate value. So this is like 0.1 minus 0.0000166, like that. So that it'll be 0.8, no, 0.9, no, sorry, 0.09, so 1 minus something will give you something less than 0.1, so it'll be 0.09, and 99, and then 1/6 will give you 8, 3, 3, and so on. Okay?
Well, there's only 2 9s on the calculator.
Oh, really? Just a minute. What am I missing? That's not good.
For the 1/6 times 1
0, 0, 9, 9.
If you go back to the 0.1 cubed times the 1/6, you move the decimal place over too much. Okay. There should be 4 places over from the 1.
Oh, yeah. Ah, okay. I need to practice my magic better. Yeah, so sorry for that mishap. I should practice my magic better. Okay, if you're unhappy, I'll give you the ticket price back. Okay. All right. So that's one thing I wanted to say. Now, there's another thing you can do with this, which is if you know the sine graph, a sine Taylor series, then you can find the cosine. How do you get the cosine of x? Well, one way to do it will be just write it as a0 plus a1x plus a2x squared and so on, and do the process again. Plug in 0, differentiate, plug in 0. You can get the values that way. However, we know that two sides are equal as functions, so what can we do? Differentiate both sides to get the cosine x Taylor series, the Maclaurin series. Okay, so x differentiates to 1. When x cubed is differentiated, 3 comes down, but wait, this is 3 times 2 times 1. So the leading 3 will cancel with 3 that came down, which will just give you 1 over 2 factorial x squared. Same thing here, 5 will come down, and this 5 factorial is 5 times 4 times 3 times 1, and because the leading 5 will cancel with this 5, you get 4 times 3 times 2 times 1, which is 1 over 4 factorial x to the 4th, 1 over 6 factorial x to the 6th, plus, and then so on and so on, okay? So now you see that cosine will only have the even terms, whereas the sine only has the odd terms. And with this at hand, you can solve an interesting question that we solved maybe 1 or 2 weeks earlier. Let me put this following question. How do you solve limit of x going to 0 of 1 minus cosine of x over x squared? Very standard question. How do you solve this?
Wow. Share the love.
No, it's not the share the love one. L'Hopital's, right? You use the fact that if you plug in 0, it's 0 over 0 type. So you differentiate top and bottom. But then it's still a 0 over 0 type, so you differentiate it again. And then you get some number. You have to use L'Hopital's twice. But that was like 2 weeks ago. How did we solve this question in Calculus 1? You had similar question. I mean, this question could be on Calculus 1 exam. Do you remember how you did it? No. You multiply what's called a conjugate. You multiply 1 plus cosine top and bottom. So the top becomes 1 minus cosine squared. And then that becomes sine squared over x squared, which is 1, and then you can do it that way. Okay. Both are not so straightforward. It takes a little bit more time. However, if you knew that cosine x is like this, then you can basically look at the question and say the answer right away. And let me tell you how you can do that. Just replace cosine x as 1 plus 1 over 2x squared minus 1 over 4 factorial is 24, right? Yeah. X to the 4th. I guess I don't need to write it. This should be plus and this should be plus. Okay, because we're subtracting, all the signs are now negated. And then you're dividing by x squared. Now this will cancel. So do you see what's going on here? If this is divided by this, what do you get?
Just
1 half. How about this one by this? You will still have x squared, but you're going to send x to 0, right? So what's going to happen when you divide this by x squared and you send x to 0? It will be 0. It will be 0. Everything will be 0 except this one when you divide by x squared. So what will be the answer?
1 half.
Just 1 half.
Well,
Yes?
How come if you just plugged in 0 right away, it would be 0 over 0 again? It's like you just have to like...
Right. So it's still 0 over 0, and you can still use L'Hopital's twice, but you can just see it right away. Like just think about like this and this, like share the log, right? So this over this, you can see that it's 1 half. So that kind of gives you an intuition behind all these things. And in fact, you can make up all these harder questions that seemingly require L'Hopital's many times. So think about this exercise problem, which I'm not going to solve, but think about this one. X going to 0 of 1 minus 1 half x squared, okay, minus cosine of x divided by x to the 4th. What do you think the answer would be? Yeah?
1 over 24.
It would be negative 1 over 24. So if you understood what I just said, you can get that answer right away. As opposed to if you use L'Hopital's, you have to use L'Hopital's how many times? You have to do 4 times. It's a lot of work. Yeah. So that's another nice thing about the Maclaurin series.